Good morning, guys. Welcome to Asynchronous Trig class. Today, we are going to start Unit 5, Trigonometry. Before we start, we're going to talk a little bit about what's upcoming in Trig. Quiz 8 will be next Monday/Tuesday at the beginning of class. It's going to be 2 questions, one on solving rational equations, one on graphing rational functions. Now, graphing rational functions, they take a long time. This is going to be a 10-minute quiz, so it is only going to be part. Maybe you only have to find some characteristics. Maybe you only have to graph it based off of a sign chart. Okay, there will be a study guide up soon, and then the key will be out this weekend. That is really your only homework this weekend because the homework on the content today is not going to be due until next Wednesday. Okay, next Thursday is Eid, and Friday is a shortened schedule because of prom. So I'm not sure what admin is going to decide. They talked about it in the staff meeting about, how to do attendance for students out for Eid. Regardless of what they do, I plan to record a separate kind of faster paced version of the lesson so you don't have to watch like 2.5-hour class. For those of you who will be out. So I'll probably just post it to YouTube unless there is a way for you to get attendance points from it. Then I'll do it to Edpuzzle. I'll keep you guys up to date on how we are going to handle that. So to start off class today, I have some questions for you. This is going to kind of lead in to what we're learning about today. So the first one is, I just want you guys to think about these for a moment or Google them to figure them out. How many degrees are in a circle? What is the formula for the circumference of a circle? What is the circumference of a circle with radius 1? And what is the ratio of the radius of a circle to its circumference? So I'm going to have you pause here, try and find these answers on Google, answer them in your head, and then answer some in the Edpuzzle before we move on. All right, so for this first one, how many degrees are in a circle? That's going to be 360 degrees. What is the formula for the circumference of a circle? 2 ways you can think of this. Circumference is 2 pi r, not to be confused with the area of a circle, which is pi r squared, or because 2r is just the diameter, pi d. What is the circumference of a circle with a radius of 1 then? Well, that's going to be 2 pi times the radius, so that circumference is just going to be 2 pi. And then what is the ratio of the radius of a circle to its circumference? So we know that the radius is r, the circumference is 2 pi r, so it's going to be, 1 over 2 pi or a 1 to 2 pi relationship. For every 1 unit of radius, there is 2 pi units of the circumference. Okay, these questions, well, I should say the answers to these questions, are going to help us when we're learning about a new measurement, a new unit of measurement today. So I want you guys to keep these things in mind because they're going to come up throughout this learning target because we're talking about circles here. So the first learning target we're going to do in this unit is I can measure angles in standard position using degree or radian measure and then also convert a measure from one unit to the other. So we'll learn that at the end because we don't want to rely on that. You're learning something new today, radians. It's a pretty complex unit, like not the unit of study, but like the unit of measurement is pretty complex. So people tend to rely on being able to convert. So we're going to do converting at the end with the expectation that, when things are in radians, you're working with them in radians. Because once you get to pre-calc, once you get to calc, you're only going to see things in radians. And it is not sustainable to have to convert them every single time. Right? We need to learn how to work with radians, right? It's like, how multiplication is repeated addition. If you just refused to learn multiplication as a kid and just said, well, I'm going to do repeated addition forever, you'd be in trouble in high school, right? So it's kind of like that, we don't want converting to be a crutch. It's a useful tool, but we don't want to rely on it. All right, so the first thing we're going to do, again, we are talking about circles here mainly with angles. All of the angles we're going to work with in this learning target are going to be on a coordinate plane, is where we're going to picture them. So imagine we've got a circle centered, the center of the circle is at 0, 0. And if there's 360 degrees in a circle, which was one of the answers to our warm-up questions, then if you go halfway around the circle, it's going to be half of that, right? Half of 360 is 180. So a half circle is 180. If you cut that in half again, a quarter of a circle is going to be 90, right? And we know that that's a 90-degree angle there. So we can find all of these units of measure by just chunking the circle, right? If we break the circle into thirds, they're all going to be 120 degrees. Okay, so take a moment and write this in your notes so you have it. These are the most popular degrees of measure, but it is also going to help us place angles. So most of this learning target is all about graphing angles. So if I wanted to graph, 110 degrees, it's important to have these two things marked because then I know, oh, okay, it falls between those, but closer to 120, right? If I want to graph 160 degrees, I know it's going to fall between these, but be closer to 150. So it's important to have more than just like the quarter angles on there. So take a second, write this in your notes. So that's what degrees are, which we're familiar with, right? Maybe you haven't seen the degrees on a coordinate plane, but degrees are something you've worked with. Radians are another measurement for angles that you probably haven't seen before. And how we get it is kind of complicated, so we're going to go through it. A radian is the angle made when we take the radius and wrap it around the circle. So it is the angle made, if I have a circle, and my radius, let's say, is 10, whatever arc length of 10 is, this angle is 1 radian. If I had an arc length of 20, so 2 of the radii or radius, this would be 2 radians. So I wanted to show you guys this little image, this little graphic of it to really show you what that means. 1 radian. And it's always going to reduce down to that because we saw when we had a radius of 10, an arc length of 10, 10 over 10 is 1. 2 radians is when we had 20 and 10. So 20 over 10 is 2. Okay, so you literally take the length of the radius, you wrap it around the circle, and that's the measure. That is what 1 radian is. Let's play it one more time. We've got the radius. We take that length. The angle made is 1 radian. So 1 radian is when you take the radius and wrap it around the circle and whatever angle is made there. But it's not just whole numbers we can measure radians in. So really what a radian is the ratio of the arc length to the radius. So if we go back to this example here, right, if I instead went 15 around the arc, that'd be 15, right? If this was an arc length of 15, the radius is 10. So this angle right here is 1.5 radians. So the measure of an angle in radians is the ratio of the arc length to the radius. Okay, it's the ratio of the intercepted arc length to the radius. Now, you don't exactly need to know this, memorize this, even honestly understand this, but it is what and where the unit of measurement comes from. and we are going to be using radians quite a bit in class this week and next. So now we need to think about the circle, right? We know once around the circle is 360 degrees, right? Halfway around the circle is 180. So now we need to think about what that would be in radians. So think about the circumference of a circle. It's 2 pi r. So if we have a circle, doesn't matter what the radius is, right? We're going to see that this will cancel out. If we have a circle, doesn't matter what the radius is, we'll call it r. If we were to find the circumference of that, that would be 2 pi r, right? Well, remember, a radian is the ratio of the arc length, which in this case, the arc length of being the circumference is once fully around the circle, to the radius. So this once around the circle in radians would be 2 pi r, because that's the arc length of going fully around once, over r. And notice r is always going to cancel. So once around the circle, regardless of what the radius is 2 pi. Once around the circle is 2 pi. So using that, we can find all of the other amounts around a circle. Right, so going once around a circle is going to be 2 pi. Going halfway around the circle then is going to be just like 360 divided by 2 is 180. It's going to be 2 pi divided by 2. So 2 pi divided by 2 would be pi. A quarter of a way around the circle would be 1/4 times 2 pi, which is going to be pi over 2. Okay, and then similar things can be done, right? This is 1/8 of the way around the circle to find all of these other ones. So I'm going to come back to this in a little bit and give you guys time to write it down. But the whole point, the real thing you need to take home is that 2 pi is equivalent to 180 degrees. Pi is equivalent to 180 degrees. Okay, you will start to, as we work with these more, they will become the same thing, right? You don't want to think of, 120 is 2 pi over 3. Eventually, they're just going to mean the same thing. You're not going to have to switch and think about it in terms of radians versus degrees. So we are going to use the fact that once around a circle is 360 degrees and once around the circle, or once around the coordinate plane, is 2 pi to help us graph angles in something called standard position. So theta is what we use to represent just any angle. So when theta is positive, when the angle is positive, we are going to go counterclockwise. So when you have a positive angle, you go counterclockwise. When you have a negative angle, you're going to go clockwise. Okay, you can see it's maybe a little easier to see if we go like that this is going clockwise. Now, the little red arrow is necessary, and it's what tells us if it's a positive or negative angle. Because without that red arrow, you don't know which way the initial side is going, right? I could just as easily go around this way, and then all of a sudden it's a negative angle. So the red arrow is very necessary, and that's how we determine if it's a positive or negative angle, or how we indicate that as well. So notice that the initial side always starts on the positive x-axis. So that's something I would maybe write down in my notes, in addition to this drawing, is that the initial side always is on the positive x-axis. It doesn't matter if it's a positive or negative angle, the initial side is always right here. Okay? Then you do your angle. I would say this is probably like 45 degrees, which is the same thing as pi over 4. So we'll say it's about 45 degrees. So you go your angle, and then your terminal side is where the angle ends. Okay, so all of these that we graph in standard position are going to have an initial side On the positive x-axis, we'll rotate around however much the angle is. Then we will draw our terminal side. Okay, so here's some examples. And again, this relies on knowing this circle, right? You guys don't necessarily have to memorize this right off the bat because you have access to it and everything is open note, but you do want to make sure you're using it. You want to make sure that when you are asked to draw 40 degrees, when you're told to draw 40 degrees, you take a look at it and you say, okay, that's going to be further than 30 degrees, but less than 45. So less than halfway in the first quadrant, right? When I am drawing these angles, I'm always asking myself, what quadrant is this going to be in? Is it going to be closer to the x-axis or the y-axis? So when I do 40 degrees here, I know that it's going to start with my initial side on the positive x-axis, because that's what I always do. Then I'm going to go a little under halfway. And again, this is a sketch, right? It should be in about the right place, but nothing is going to be perfect. We're not getting out protractors here. And then I'm going to place my terminal side as well. Okay. For 160 degrees, what I would look at is I'd say, okay, so it's past 90. It's in the second quadrant, and it's decently closer to the y-axis than the x-axis, than the y-axis, right? It's going to be closer to here, and it's, decently over half, but it's a little closer to halfway, or a little closer to the y-axis, so we'd place it right about there. Okay, so that is how we get 160 to be like this. And then the last one, negative 320. The negatives are always kind of tricky because we don't have a unit circle that has the negatives automatically on it, but we just know it's going the opposite direction. So, this would be negative 45 degrees, and this would be negative 90 degrees. This is negative 180, right? Negative 270, okay, and then, just past 270 is 300, so this is going to be negative 300, negative 330, negative 315 up there, sorry. Negative 315, negative 330, and negative 360. Right, so we can still use the idea of this circle to help us place, okay, 320 is going to be a little over halfway. Right, and what you were told to notice is that if we just look at these angles, the initial side and the terminal side are in the same exact spot, right? These two angles without the red arrow are exactly the same. They are identical. And that is something that we say is coterminal, which makes sense because they share a terminal side. They have the same initial side, the same terminal side, but they are different angles because they're going in different directions. All right, let's do some examples and see if we can make some sense from this. So when I'm first starting these out with you guys, I'm really going to label the sides to help us figure out where to place these angles. Now, I've been working with radians and degrees for a long time, so I kind of know in my head about where these are. But for us, when we're starting, we really want to label them as if they are this kind of circle to see where angles are. So the first thing I do is I determine if it's going to be clockwise or clockwise or counterclockwise. So this is a positive angle. So I'm going to pause here real quick, and you guys are going to tell me which way it goes. Yeah, this is going to go counterclockwise, right? Positive angles go counterclockwise. Just like how we count our quadrants, 1, 2, 3, 4. I drew a 3 here, but I meant 2. We go that direction for positive angles. So I'm going to put my initial side on 0. And then I'm going to label my sides. All right, since I'm going counterclockwise and each quarter turn is 90, I'm going to go 0, 90, 180, 270, and 360. And what this allows me to do is place the quadrant this is going to be in. I know that this is going to be in quadrant 4, right? I know it's going to be in quadrant 4 because 290 is between 270, and 360. So the first thing I figure out is, okay, I'm in this quadrant somewhere, right? Now that I'm in that quadrant, I need to determine two things. First, well, one thing, am I closer to the y-axis, the x-axis, or the middle of the angle? So the first thing I do is I go back here and I see, okay, in the fourth quadrant, the middle angle is 315. So if I was here, that would be 315. So 290 is now between 270 and 315. Again, this is not things you have to actually write out. This is what I do in my head so that I can figure out where the terminal side should be. So then I see, okay, well, 290 is just a smidge closer to 270 than it is to 315, right? It's 25 degrees from 315, 20 degrees from 270. So my terminal side is just going to be a little closer to 270 here. Okay, so then I have my angle. But if I just get rid of all this and then I'm just looking at this, I don't know, is this 270 or is this like a negative angle, right? Remember, I always have to put my direction, right? And say, okay, this is going this way because it's a positive angle. It's going counterclockwise. Okay. So then I'm going to do a very similar thing with the next one, except for notice the big obvious difference is that this one is negative, right? The angle is negative, so that tells us that it's going to go clockwise. Oops, that went the wrong way. That's going clockwise, and that's the way I'm going to count my angle. So instead of going 0 here and then 90 here, I'm going to go 0 here and negative 90 here. And then this is negative 180, negative 270, negative 360. And I'm trying to graph negative 175. So I see that negative 175 is between negative 180 and negative 90. So I'm going to put my initial side is going to go here because it always goes here. Your terminal side is your initial side is always on your positive x-axis. Okay, then I'm going to be in quadrant 3 because it's between negative 90 and negative 180, and I don't even feel like I need to draw the middle thing, right? The middle thing would be 135, but to me it's pretty clear that negative 175 is real close to negative 180, right? We're going to be just barely not hitting the x-axis over here, right? Barely not hitting it. So there's my terminal side. Last but not least, I always need to draw my angle my arrow from my initial side to my terminal side so I know which direction it goes. All right, I want you guys to try this one on your own. So take a pause. Try to graph this one on your own. You've got how to do standard position in the bottom right corner, in the top right. You have all of the possible angles. So I want you guys to pause this, try this on your own, and then we'll see if you get it right. Okay, here is your answer. So, did you get it right? Okay, let's explain this one. So what we do here is, again, this is a negative angle, which means our initial side is still going on our positive x-axis, but we're going to go clockwise. So we'll have 0 degrees here, negative 90 here, negative 180 here, negative 270, and then negative 360. So the first thing I can figure out is I know that I am in this quadrant, right? I am in quadrant 1 because negative 345 falls between negative 270 and negative 360, right? Then once I determine that it's in the first quadrant, I'm starting to think about, okay, what's halfway? Halfway is right about here, and halfway would be negative 315. So negative 345 is going to be closer to the x-axis. So honestly, I could probably move this a little lower if I wanted to get real technical, right? I could probably make it a little lower because before it was about halfway between negative 315 and negative 360, but negative 345 is going to be much closer to negative 360 than negative 315. So we'll put it right there. Okay, and that is how I determine where it is. So the next thing we're going to look at is what if it's greater than 360 degrees or greater than negative 360 degrees? How do we graph that? And the answer is kind of probably what you would have guessed. You just go around and around till you've hit it, right? Once is 360 and every quarter turn more is 90. So you just keep adding that until you get to a place where it ends up being. So the way that we will start this is we will have, as always, our initial side is along our positive x-axis. So our initial side is along our positive x-axis. Then for this one, we're going to go counterclockwise because it is a positive angle. And we know that fully once, going once around completely, is 360 degrees. Right? So if I put my terminal side right there, if I left it right there, that's a 360 degree angle. But obviously I'm trying to go 585. So the next thing I would do is I'd add 90, right? It's important to know that every quarter turn is pi over 2 or 90. Okay, in this case we're working with degrees, so we're going to think in degrees, but every quarter turn is 90 degrees. So I go a quarter turn more, that's going to be 450 degrees. Okay, I go another quarter turn, that's another 90 degrees, that's going to be 540 degrees. Then I go another quarter turn, that's another 90 degrees, this is going to be 630. And now I don't have to keep going because I know that this is going to fall somewhere in quadrant 3. I know this because 585 is between 540 and 630. And we kind of want to think about which one it's closer to. In this case, it's dead center, right? It is dead center. So that's where we're going to draw our terminal side, right? They're both 45 degrees away. So we'll draw our terminal side, dead center. And then we need our internal arrow that shows the direction to also go to there. So that's one way that you could do this. That is one way you could graph this. Another way is if you know that 360 is a full way around, you can do a little bit of subtraction and you can say, okay, let me do 585 minus 360. That's 225. So you know that it is going to end up on the same side, right? 585 and 225 are what we called coterminal angles, right? 225 looks like this. Well, 525 is just that same thing, but you're going around one more time. So there's two ways you can think of it. I like to write on my axes and say, okay, this is 450, 540, 630, and think of it that way. But you can also just think of it as a subtraction problem until you get to a number that falls on this circle. All right, so now we're going to do the same thing, but with radians. Now this one, pi over 4, falls on what you're going to come to know as the unit circle, right? It is one of those common angles. The only tricky part here is that this is negative, right? It's not going to be this pi over 4. It's actually going to be 7 pi over 4 because it's going the other direction, right? So the thing to keep in mind when we are doing radians is that pi over 2 is halfway around a circle. So, a quarter of the way around a circle. So pi over 4 is an eighth of the way around a circle. So we're going to draw our initial side, as we always do, on the positive x-axis. And then there's a couple ways we can think about this. One way we can think about this is I know this is 0. This is going to be negative pi over 2, negative pi, negative 3 pi over 2. Right? I can think of, okay, halfway up is pi over 4, so negative pi over 4 is going to be halfway down. Right? That's one way to do it, is literally just think, okay, if this was positive, it would be here, right? But it's not, it's negative, so it's going to go this direction, but be just as much. Okay? The other way you could do it is by finding a coterminal angle. So a way we can do that, it's kind of similar to how this one, an option was to subtract 360 until we got an angle that falls, between 0 and 360. When it's this, you can add a full rotation until it's positive, right? Because if we look at this, on our unit circle we've got here, we only have positive angles and angles between 0 and 360 or 0 and 2 pi. So if we add a full rotation, so negative pi over 4 plus 2 pi, that will give us where the terminal side would be on the unit circle, right? Because 2 pi is going to be the same thing as 8 pi over 4. Add across the top, 7 pi over 4. So that's another way we can see that the terminal side must be at 7 pi over 4. But again, this would be 7 pi over 4, but since it's a negative angle, our arrow is going to go inside. Okay, so things are obviously a little more complicated when it comes to radians, but that's really just because we're not used to them. And the more you practice with them, the more comfortable you'll get and the easier it'll be. And the good thing is, no matter how hard of an angle it is to graph, the strategy stays the same. So long as you follow the basic steps, you should be able to get it. So the strategy I'm going to advise you to use, that we saw honestly with degrees as well, is to label the axes, right? Always label the axes. The tricky thing is, unlike degrees where we're just working with numbers, when we're working with radians, oftentimes we are working with fractions. Most radians are fractions. Fractions can only be compared if they have the same denominator, right? If I had, let's just say for fun, if I had 6 over 7 versus 11 over 13, it's quite difficult to tell which one is larger, right? One way to do it would be to turn them both into decimals and determine which decimal is larger. Right? But the other way is to give them the same denominator. So these don't have a common denominator. They don't have a GCF. So we'll multiply 6/7 by 13 over 13, and that will give us 78 over 91. And then over here, we'll multiply 11 over 13 by 7 over 7, and that's going to give us 77 over 91. And now we can see that these are actually very close in size, and that 6/7 is just a smidge bigger, because once they have the same denominator, you can just compare the numerators, right? Now that they're both out of 91, I can just say, okay, is 78 or 77 bigger? So what we're going to do is we're always going to make sure when we're labeling the axes, we're doing so in a denominator that matches the denominator of what we're graphing. So in this case, we just really used the fact that it was on the unit circle to figure out where it was. But actually, what we would want to do, instead of rotating negative pi over 2 every time, right, instead of going around negative pi over 2, we're going to think of everything in terms of over 4. So negative pi over 2 is the same as 2 pi over 4. So that's how we're going to do this, right? We're going to go 0, negative 2 pi over 4, negative 4 pi over 4, and negative 6 pi over 4, negative 8 pi over 4, so that when we're asking ourselves, okay, where does 1 pi over 4 fall, all we have to do is look at the numerators. All I have to say is, okay, negative 1 is halfway between 0 and negative 2. Again, for this one, it's already on this unit circle, so we don't need to do it this way, but that's what I mean. It's much easier to compare fractions when they have the same denominator. So that is going to be our strategy going into graphing some interesting radians, right? So if I wanted to do 11 pi over 18, okay, first thing I like to do is decide if it's going clockwise or counterclockwise. This is a positive angle, so it's going to go counterclockwise, and sometimes I just draw this to remind myself what way that means. Then what I want to do is write everything with a base of 18. And the way I do this is, since I know every quarter turn is pi over 2, if I can write pi over 2 with a base of 18, then I can just count up by whatever that is, right? So normally I'm counting up by pi over 2 because that's what a quarter turn is, but I want it to be over 18. So I've got to do a little side thing here. If I've got pi over 2, I want to figure out what my numerator needs to be to make that over 18. And there's a couple of options. You could cross multiply here, but really you're just going to take your denominator and divide by 2. That's always what it's going to be. So 9 pi over 18 is the same as pi over 2. So instead of that additional pi I'm adding with each rotation of a quarter turn, really that's the same thing as adding 9 pi over 18. But that's going to give me a better comparison point because it has the same denominator. So I'm just going to start with 0. Then I'll add 9 pi over 18. So this will be 9 pi over 18. Then it's another quarter turn, so I can add 9 pi over 18 again. Okay, when denominators are the same, we just did this in unit 4, you can just add the numerators. So this is going to be 18 pi over 18. We could keep going where I add another 9 and I have 27 pi over 18. Then 36 pi over 18, but really we only needed to go halfway because we know, we can see that, okay, 11 pi over 18 is less than 18 pi over 18, but it is greater than 9 pi over 18. So we know that this terminal side is going to be in this quadrant here. Okay, so we've got our initial side going on the positive x-axis, and we know our terminal side is going to be somewhere in quadrant 2. Again, the way we figure this out is we take a look at which one it's closer to. We ask ourselves, is this angle going to be closer to 9 pi over 18, closer to the y-axis? Is it going to be closer to the middle? Or is it going to be closer to 18 pi over 18? And really all you need to do is think about 9, 11, and 18. You just ask yourself, is 11 closer to 9, 18, or closer to the middle of them? And I think when you think about it like that, it's pretty clear, okay, 9 is closer to 11, so 9 pi over 18 is going to be what we are closer to, right? And we can see that it's going to be broken down into about 9 pi over 18 pieces, so we will just put it just past, not too close, but just past the pi over 18. And now we've graphed this problem. So it's just really, really important that you make it so the denominators are equal so that you can figure out where this is. Okay, now you do not have to do it exactly in this way, but it is not an option to just switch everything to degrees, right? One of the main points of this learning target is to introduce you to radians and get you working with them because you see them so much in pre-calc and calc. All right, we're going to do one more as a class, and then I'm going to have you guys try one on your own and submit it to a Dropbox on Schoology. Okay? So this one is 31 pi over 9. None of the angles on my unit circle are over 9. I don't know where to place this when comparing to over 2, over 3, over 4, or over 6. So what I want to do is label my axes and think of everything in terms of 9. Because when denominators are the same, you can easily compare numerators. So the first thing I need to do is say, okay, a quarter turn, right? Remember, a quarter turn, and again, we're going positive because we're going counterclockwise because it's a positive angle. I've got my initial side that's going to go there. So then I say, okay, I know a quarter turn is pi over 2, but thinking of 31 pi over 9 in terms of where that would be is difficult because there's nothing over 9. So I want to rewrite pi over 2 as being, something over 9. You can cross multiply to solve this, right? Or you can just know that it's always the denominator divided by 2, right? Pi over 2, that's going to simplify to 1/2. And then 4.5 over 9, that's also going to simplify to 1/2. Okay? So what this tells me is every quarter turn around the circle, I'm going 4.5 pi over 9 more. So I start at 0. Then I go 4.5 pi over 9. I go another 4.5 pi over 9, right? Every single quarter turn is pi over 2, which in this case we're thinking of as 4.5 pi over 9. We just did this in the last unit. When the denominators match, you can add the numerators. So 4.5 plus 4.5 is 9. So this is going to be 9 pi over 9. Right? Notice, really, I'm just adding 4.5 to the number every time. So 9 pi over 9 plus 4.5 pi over 9 is 13.5 pi over 9, right? Basically, 9 plus 4.5 is 13.5. 13.5 plus 4.5 is 18, so this is going to be 18 pi over 9, which makes sense because that reduces to 2 pi. And we know once around the circle is 2 pi. Okay, that's not enough though, right? We have not gone far enough, clearly, right? 31 pi is more than one rotation around. It's greater than 18 pi over 2. So we're going to keep going. We're going to keep counting. So here I'll go another 4.5. It's going to be 22, not 22.25, or not, yeah, I don't know what I wrote there. 22.5 pi over 9. And then I go another 4.5. This is 27 pi over 9. I go another 4.5. I've got 31.5 pi over 9. So I could keep going. I could keep going till I'm like, okay, this is 36 pi over 9. But I don't need to because I've already figured out what quadrant it's in. Okay, I know that 31 is between 27 and 31.5, right? 27 is less than 31, which is less than 31.5. So I know that I'm in this quadrant because, again, notice once we get a similar denominator, all we have to do is compare the numerators. I should also notice that 31.5 is significantly closer to 31 than 31 is to 27. So I should know that my terminal side is going to be quite a bit closer to 31 than it is to 27. So let's go ahead and let's put our initial side down. Our initial side goes on our positive x-axis. Okay, we go fully around once. We fully go around once to get to 18 pi over 9. It's not enough. Then we go all the way to 27 pi over 9. And then we go just about to 31.5 pi, right? Because this is a distance of 4.5 pi. So 0.5 away is going to be pretty close. And then we will draw our terminal side. Okay? All right. So last but not least, I'm going to have you guys do and turn in this problem. So first, I want you to pause here, and then when you're finished, answer the question. Then I'll go over it with you guys, and you can either turn it in before or after we go over it. Okay, now I want to be able to get you started, give you some hints. So the first helpful hint we're going to give is that this is a negative angle. And we know that negative angles go clockwise. So our initial side, in the same place all the time, but our angle is going to go clockwise around the unit circle. So when we label our axes, we are going to go this direction. So if this was just normal, this would be 0, this would be negative pi over 2, negative pi, and so on. But again, to be able to place negative 25 pi over 18, I need to have similar denominators. So I'm going to the first thing I'm going to do is, instead of going, negative pi over 2 every time, I need to think of pi over 2 with a denominator of 18. And again, I just take half of the denominator because 9 over 18 simplifies to 1/2. And so I get that a quarter turn in the clockwise direction is negative pi over 18. So I would call this 0. This is going to be negative 9 pi over 18. And then every quarter turn, I'm going to be subtracting negative pi over 18. But because they all have pi and they all have the same denominator, it's really just a matter of saying, okay, negative 9 minus 9. And then negative 9 negative 18 minus 9 is negative 27 pi over 9. 18, my apologies. And then negative pi over 9 over 18 more is going to be negative 36 pi over 18. And then I ask myself, where does negative 25 fall? Right now that I have common denominators, I can just look at the numerators and say, okay, negative 25 pi falls between negative 18 pi over 18 and negative 27 pi over 18. So I know it's going to be in quadrant 2. Okay, I'm not actually going to graph this because I want you guys to graph it on your own, but I'm going to talk you through it. So I want it to be in quadrant 2, or I know it needs to be in quadrant 2, because that's the quadrant right here where we've got between 18 and 27. So I'm going to put my initial side on the positive x-axis, and then I know I'm going to be, ending up in this quadrant somewhere. How do I figure out exactly where? I need to determine, is negative 25 closer to negative 27 or closer to negative 18? And because it's closer to negative 27 by a decent amount, right? And you can also think about like halfway. What halfway mark would be about 4.5 in each direction. So it's going to be decently closer to 27. So I'm feeling like our terminal side is going to be around here, So then you put all those pieces together. You've got your initial side here. You make your curve go in the right direction, and then you put your terminal side on, and then it's done. Then you're good to go. All right, so go ahead and submit this to Schoology. All right, so now that you have submitted that to Schoology, I wanted to remind you again of the same exact conversation we had at the beginning of the class. You've got quiz 8 next Monday, okay? It is going to be 2 questions, solving rational equations, graphing rational functions. The study guide will be up soon. You need to keep an eye out for the key this weekend, okay? And then next Thursday for Eid, I'm not sure how admin's going to do attendance, but I will make sure to have something recorded for you guys. So your main homework this weekend is studying for quiz 8. Right, you actually, even if you wanted to complete the entire CUDA worksheet, would not be able to, right? We've only done about half the stuff on it. So that is available for you to start this weekend if you want to get a head start, but it'll actually not be due until Wednesday morning, right? It'll be assigned to you guys again next Monday. Okay. So that is all I have for you. I hope you were able to get something out of this lesson. It'll be on YouTube by this weekend so that if you need to go back and watch parts, you can. Email me if you have any questions. And I guess, I'll see you guys Monday. Have a great weekend.